This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio brings you relevant and detailed discussions and interviews on software engineering topics every 2 weeks. Thanks to our audience and the partners listed on our website for supporting the podcast.
Okay, welcome listeners to another episode on Software Engineering Radio. Today we have Kent Beck on the mic. Talk with him about the history of JUnit and the future of unit testing. So welcome, Kent.
Thank you very much. It's great to be here.
Great to have you on the show. Would you introduce yourself to our listeners? Tell us a little bit about your history and your background.
Sure. Well, I'm a third-generation geek. My grandfather was a radio geek. My dad was an electrical engineering geek. Turned programmer geek, and now I am, and now my oldest daughter carries on the family tradition. So I grew up in an environment with lots of technology around. Started programming when I was about 12 or 13, maybe 11, on a programmable calculator my dad brought home. Let's see. I don't know what kind of highlights the listeners will find interesting. I've done a number of things. Software patterns were something that I worked on early on. Extreme programming, test-driven development, the JUnit architecture, which was first implemented in Smalltalk, and then translated into Java by Eric Gamma and myself. Responsive design. What else? What else are you interested in?
You wrote a lot of books, correct?
Yes, I think I've written 8 books so far.
Oh wow, that's a lot. I think they're pretty famous in the community, right?
Yeah, by geek standards, yes.
Okay, great. And I think I read on Twitter that you're a great fan of the SE Radio episodes. Is that correct, or?
Yeah, so I live on 8 hectares of mixture of meadows and forests outside of a little village, which is outside of a slightly larger town in the middle of nowhere in southern Oregon. So I have a lot of farm chores to do, and I listen to lots of podcasts, including having listened to, I think, all of the episodes of Software Engineering Radio. It's great when you're shoveling manure to be able to tune into something to feed your brain while you're taking care of that or feeding the animals or whatever.
Yeah, cool. I think it's a great honor to have you as a listener of all the episodes. Yeah, it's great, cool. So can you tell us a little bit about the history of JUnit, how things began?
Sure. So my first commercial work was in Smalltalk, and Smalltalk had a history of testing, but not automated testing. So you'd make a few changes to your programs, and then you'd run a little bit, and then you'd make some more changes. And it was set up for that kind of very incremental cycle. But there weren't automated tests. I did a series of experiments. So I tried 4 or 5 different techniques for writing automated tests. And then one day I was asked to give advice to a development project early on in my consulting career. And I knew I was going to tell them to write automated tests, but I didn't have a way for them to write automated tests. So kind of in a panic, I said, let me take this structure that we use for testing in Smalltalk, this workspace structure where you'd have some variables that would get initialized and then you'd have expressions. And I said, well, what if I just turn that naively into an object model? So the workspace is a class. The variables that you use become instance variables. The little snippets of code that you use to test become methods. So it was just really kind of the naive mapping. And then rather than doing manual testing where we'd say, you'll print this value out, and then you'd make sure that, yes, it printed out ABC, I said, well, let's have the computer do that. So that's where the assertions came from. So that was the origins of the architecture. And that's got to be in 1980, I can't remember. Yeah, I don't have an exact date for you, but it's got to be in the 90s, 92. So that's when the first unit testing framework that I did that was at all successful came from.
Wow.
Fast forward a few years, I was living in Zurich, and Eric Gamma and I would get together and program from time to time. And Java was fairly new at that time, and I wanted to learn it. So we were on the plane going to Uppsala, and he'd heard me talking about this testing architecture, and I'd heard him talking about how cool Java was, and so we just sat there and built the first version of JUnit, test first from the very first, which is an interesting bootstrap problem, right? How do you test a testing framework so that if it breaks, you know that it breaks? So we like those kind of intellectual challenges. So by the time we were done with that plane ride, we had the first version of JUnit. We gave it to Martin Fowler. But it was so small, right? JUnit is so small. How could this possibly be valuable? So we gave it to Martin Fowler there in Atlanta. He tried it out immediately and said, "This is cool." So we gave it out to several more people, got really good feedback, and that's pretty much how the whole thing started.
Wow, and it's a pretty successful story, right? Today, JUnit is the de facto standard for doing automated unit testing in Java, right?
Correct.
So what happens since then? It's a long time ago. What happened to JUnit in the meantime?
Yeah, so that was in 97 that we wrote the first version, and so it's gone through. It's now on version 4. It's gone through one big architectural change, which was the switch from subclassing, a framework sort of metaphor where you subclass something and overrode certain methods, to a DSL metaphor, which you implement in Java with annotations. So I had seen NUnit very early on, when it was just a few files on James Newkirk's machine, and seeing the annotations and thought, this is a cool idea. And then I realized, well, a lot of the way that, for instance, methods used to have to begin with the letters TEST. Well, that's a kind of metadata, because we would go and interpret that. JUnit is a language. It has semantics. They're different from Java semantics. For example, inheritance runs differently than it does in Java. So we were using the language we created this language in Java that wasn't really Java, and interpreting it. But with annotations, now all of a sudden the compiler can give you help again. Because if somebody named their test TSET, it just wouldn't run, and there'd be no way to tell. But with the annotation, you know whether it's spelled correctly.
There are a lot of other language implementations of the JUnit framework, a lot of translations to other languages. What do you think of this movement?
Well, I think I can interpret it on a couple of levels. One level is this is a successful design. It means that there is something common to tests. That is, that you want to run these isolated chunks. You want to be able to compose them together and not have them interfere with each other. And you want to do that all in the source language. There's huge advantages to not having your testing language be your source language, but there's also huge advantages to keeping the source language and the testing language have it in the same language as it is with JUnit. So kind of there's this attractor in the space of design tools, and it draws a lot of functionality into that same basic shape.
today, who is implementing the current versions? You're still working on it, right?
Yes. So every week, David Saff, who's at Google now, and I get together and work on it for a few hours.
Oh, every week?
Yeah, pretty much.
Wow, cool. So you're already planning the next version?
Yes, we're already working on it. We don't have a big new theme, I would say. The last version came out with a really cool feature, which is kind of working its way through the community. That's one of the things, the advantages of having a project that lasts for 13 years is you learn a little bit the value of patience. So, just if you come up with a new feature and you think it's fantastic, 5 years later, if people are using it, then yeah, that was a really cool feature. But you can't tell after, if it's only been 3 years and people still aren't using it, then you still don't know whether it was really cool or not. So, and that was what we call rules, which are kind of let's see, what's a simple way to explain it? So when your test runs, this chain of objects is created. That one object will run the before methods, and another object will catch timeouts, and another object will report errors. Well, you can insert, using rules, you can insert objects into this chain. So it's kind of a meta object for testing. And so it was a big deal. People are using it for all kinds of cool stuff. Rather than having to use inheritance to capture the commonality of tests, now you can use composition, which is a whole lot more flexible. So if people are looking for the cool stuff in JUnit, that would be something to have a look at.
So you think it's a key feature to reuse stuff in your unit testing code?
I don't know if it's a key feature because we went 13 years without it. So, but I think it is very useful, certainly for capturing. I mean, I always strive for a kind of declarative expression in my tests. You should be able to just kind of read a test and it tells a story. And rules are a way of setting the stage for a test in a way that's obvious, that you can read right there, but at the same time can be quite simple. So you can have a rule that creates a temporary folder, and then all of the stuff that you do in your test that does file manipulation, when the test finishes, the folder is automatically deleted. So in reading the test, you can just say, oh, look, there's a temporary folder. I'm sure there's some file manipulation going on in here. So rules give, in an imperative language, this still gives it this very declarative feel, which I think is valuable for tests.
Okay, so it's not only this kind of reusing stuff, but also to make it more expressive, right?
Yes, because every test should tell a story, right? It should have a beginning, a middle, and end. It should have a kind of a flow, an arc, and it should have a moral. Right? What's the point? What's the point of this test? You should be able to read that out of the tests. So rules give another way of setting the context for tests that's a little richer than anything that had happened before.
And it's introduced in version
4.8, I think.
4.8?
Yeah, which is what you can find on GitHub. That's where we host now after a long and successful run on SourceForge.
Oh, okay, great. So you also mentioned these that you worked on or maybe you coined the term test-driven development. So can you give me a very brief introduction what test-driven development is?
Yeah, it's this crazy idea that the best ideas are the crazy ones, right? If you have a crazy idea and it works, it's really valuable. If you have a fantastic idea and it works, who cares? Right, because somebody else will have thought of it. But if you have a crazy idea and it works, then you really have something. So it's this crazy idea that when you want to code, the first thing you do is you write a test that fails that will only succeed when the code that you're imagining is actually in place. So it turns the workflow of programming backwards.
What do you think is the most important point when you do test-driven development? Is that you think about the design first, or they drive the implementation from the viewpoint of a user of the class, for example, because you write the test first, or is it something else?
Here's what happened to my head after I'd been doing TDD for a couple of years, and that is I would imagine some functionality, and my next thought was, how am I going to test that? Always before, I would imagine some functionality, and then I would think, I could subclass this and extract that as an object and replace it, and a bump, a bump, a bump. It's all about implementation. And now, when I think about functionality, my next thought is, how am I going to test that? What it does for my thinking is that trying to imagine the implementation and how I will know that it's correct at the same time, because I make mistakes, is a big job. Sometimes it's too big for me to hold in my head. If I can divide that into two parts and handle the how am I going to test this part first, then I have a smaller, less stressful, easier to focus on problem to deal with. Namely, how am I going to test this? Oh, well, if you can't write a test for it, you got no business programming it, which is true for most programs. Now, when I'm being very exploratory, I don't worry about this stuff. If I just want to say, can I get a program that does X at all, then I'll just sling code and check it manually. Then once I discover, yes, this is possible, then it's a good time to switch gears and say, okay, now, let me go back and let me implement this a little at a time and figure out how I'm going to test this.
For many people where I talk with, they still think that doing the test before the actual code is really a crazy idea. And there's some maybe sometimes they're afraid of doing this kind of stuff. What is your observation of the adoption of test-driven development in practice, in industry, and in the wild?
Well, I'm really curious, like what could go wrong? Your head's not going to explode. Like what? So do you do TDD?
Yeah.
So what do you say when somebody says, oh, this isn't going to work?
Typically, I say it helps me just go forward in small steps and keeps me going at a sustainable pace in small steps. And it just helps me thinking about what I need to do and how can I possibly implement this stuff.
Yeah, that's the sense that I have. That's my experience of it as well. Now, it is, I think some of the barriers are probably social. Because when I went to computer science school, back when we had to dig our own sand for our own transistors, the A students got to be programmers and the B students had to be testers. So part of what I had to overcome was just kind of this social status. Oh, I'm a programmer, I don't have to write tests. And like I had to overcome that, that I was somehow lowering myself to write tests, which isn't true. I mean, that makes no sense, but that is the human brain we're talking about. So, I don't know if that's part of what the people you're talking to are encountering, but that was certainly a barrier for me to think, I should spend 30-40% of my time recognizably writing tests. Now, when I'm writing tests, I'm not just writing tests. I'm making API decisions. I'm making analysis decisions, and the tests just happen to be the notation that I use to record those decisions. But at the end, I still do have a bunch of tests that actually run.
Do you think you've convinced most of the people you talk to?
I don't know, because I'm not. I don't try to convince people anymore. I think I spent probably 10 years really trying to convince people, TDD, pair programming, you should do this, you should do that. And I don't do that anymore. I'm always working to improve my own practice. I am eager to share what I learn, and I try and listen and understand what other people have learned in their experience as well. So I don't really keep score by how many people do TDD. If the practice of software development is improving overall, then I think that's a great thing. And if I have some small influence on that, then I think that's a great thing too. Well, so you ask a question about do people, like, how widespread is TDD? Um, I think it's still a very small percentage of people that are like won't write a line of code unless they have a test that's failing.
Mm.
Under for production coding. But I think there are a very large number of people that have been exposed to tests and the potential value of tests. But I still go places and people say, oh, yeah, we did a bunch of tests, but then the tests stopped working, so we threw them out, which just seems bizarre to me. I mean, like Aristotle would be shocked, right? The logic just doesn't add up. This test says, if the test is running, my program's running, and if the test is not running, then my program's not running. And the test stops running, and your next act is to delete the test or just stop running it or ignore the test report that you get. Like, wow, that means your program's not running. But somehow, I mean, there's a lot of other pressures on people other than get your program running. I guess that's the conclusion that I can draw from that. But it's too bad. I think there's potential value there. People could produce more value as programmers if they trusted the tests and paid more attention to them. But there's a lot of other things going on in software development than coding.
There are other, let's say, maybe test philosophies. For example, some people call it behavior-driven development instead of doing test-driven development. What do you think about that?
Well, so the big picture I think is very positive. Programmers actively taking responsibility for the quality of their work. I think that's a good thing, and whatever you call it, kind of that's a second order effect. Something I didn't communicate very effectively in my first discussions of TDD is the importance of testing at various scales. So TDD is not a unit testing philosophy. I write tests at whatever scale I need them to be to help me make my next step of progress. So sometimes they're they're what somebody else would call a functional test. So, for example, 40% of the tests of JUnit work through the public API. 60% of them are working on lower level objects. The public API is quite good for testing, probably because we've written so many tests. So I don't know if those proportions are I don't want to claim those proportions are anything more than one data point. Like, should you have 40-60? Should you have 10-90 or 90-10? I really don't know. But just this idea of moving. Part of the skill of TDD is learning to move between scales, right? So I write a test that my customer says, oh, blah, blah, this scenario should result in a 5. So you write a test that says this scenario should result in a 5. And then you're down in the deep in the intestines of your program and you're thinking, oh, I see. Well, this object, when given a 5 and a 7, should return the 5. Well, that's a good place to write a test because that's another piece of the story that needs to be told. But, is that acceptance test driven development or is that BDD? I think that erecting rigid walls between the styles is actually a mistake. Like the scales, as a programmer, I want to understand all those scales. Tests help me understand, so I write tests at all those scales. Does that answer your question?
Yeah, I think so. And it also leads me to another one about scaling unit testing, because I saw projects having thousands and thousands of unit testing, and they had problems, let's say, dealing with all those huge amounts of unit testing. What do you think about this kind of, does unit testing really scale on, let's say, on the small level, not the acceptance testing level, but on the small level, you have thousands of classes and huge amounts of unit testing code, maybe 2 or 3 times as much unit testing code as your actual real production code. What is your experience with that?
Well, I would say That's 2 to 3x testing code to production code. The production code have to be pretty complicated, but that's well within the realm of normal. The guy I learned the most about testing from was a compiler writer, and he had 5 lines of tests for every line of compiler that he wrote, and he was the most productive guy that I'd ever seen. So that was a real inspiration to me. But he's working on a compiler which is, extremely complicated inside. So if it was 1-to-1 or 5-to-1, that wouldn't bother me.
But you still think that you need some kind of, let's say, test-driven development or testing, automated tests on different levels of scale, right? So you have these kind of very small tests for very small units, some API stuff, some acceptance level stuff.
Yeah, no, Saf claims that, David Saf, the other current committer on JUnit, he claims that tests tend to migrate either to the lowest level of objects or the highest. And he was talking about tests for Eclipse applications, and so I can believe that. I don't know if that I've really noticed that in my experience. I think that I have some tests in kind of the middle level that I'm happy to have and that don't cost me too much.
You already mentioned that you, for example, if you would like to figure out if it's possible to implement X, you don't write a test for it. If you just would like to figure out, is it possible to implement this? Are there other situations where you think you do not test-driven development, but the other way around? So I remember a tweet on Twitter saying something like good developers know when to test and when not to test. Can you explain us a little bit?
Well, so with tests you've got costs and benefits, and some of the benefits are short-term and some of the benefits are long-term. Some of the costs are short-term, some are long-term. And different situations have different profiles of short and long-term. So, for example, I threw together a site called pokerworkout.com because I was learning to play poker and I was having trouble doing the pattern matching, just figuring out I have 7 cards. What kind of hand do I have? Do I have a pair? Do I have 2 pairs? So first, I just wanted to know if I had a program like this, would it be fun to use, and would my recognition skills improve? So I just banged it together, first version in Smalltalk, then I translated it into JavaScript, and I didn't have tests, but I discovered, yes, this is fun to play. So then I wanted to expand it to, more situations, and I had to make the domain model richer and to cover more of poker. And when I did that, then I started writing tests. And when I started writing tests, I discovered, that the design was, the chunks were too big, so I had to pull pieces out, and then I could write tests more easily for them. But there's this transition period. At first, right, I could easily have said, is this fun, useful at all? And the answer could be no. So all the long-term benefits of having carefully written tests for that are gone, because the half-life of the program is so short. Once I say, yes, this is good, and yes, I want to maintain it, and yes, I'm going to live with this code for a while, then the long-term benefits kick in. They become, more probable that I'll be able to reap benefits long-term. So then I need to kind of switch gears. But overall, that's what I'm thinking about. What are the costs and benefits, short-term and long-term? So when I started JUnit Max, which is an Eclipse plugin, writing tests for Eclipse plugins is notoriously difficult. And I wrote a book about it with Eric, and I still find it a real challenge sometimes, because the API is extremely powerful and flexible, but it's not set up for isolated testing very well. So when I started JUnit Max, I didn't have automated tests. Not because I knew I was going to live with this code for a while, because I just knew that Max was a great idea and I wanted it for myself and I'd maintain it for myself if no one else. But the cost of writing those tests was going to be extremely high, especially the first few of them that I wrote. So for the first, say, month that I was developing Max, I didn't have any automated tests. I did all my testing manually. At some point, the complexity of the code got to where I started worrying about, if I change this, am I going to break something else? And that's when I had to, as we say in English, bite the bullet, do something difficult in spite of its difficulty, and just start writing tests. Now I have, I was going to say lots. I have sufficient tests, automated tests for Max. But in that exploratory phase, because the short-term costs were so high, even though I knew I was going to reap the long-term benefits, I still didn't write automated tests for that. And again, I had to become aware of this balance. I'm waving my arms around here, which doesn't really help you, I understand. I had to become aware of where this balance shifted to where the costs and benefits, short-term and long-term, now said, yes, the previous feature I did without an automated test, and this feature I'm going to do with an automated test, even if I have to pay a substantial price to write that test. And I was happy with how that worked out. So I think that's what I'm thinking.
Yeah, it's very interesting, because I also know people that are much more dogmatic about unit testing and test-driven development, and they say before you implement a single line of whatever it is, do test-driven development because it helps you thinking about the piece of code, designing the piece of code, whatever. And they are very much more dogmatic than you are. It's interesting to see different opinions about this.
Well, I think it's worth being dogmatic as a learning tool, right? What if I just said I'm always going to write tests for everything, and then you discover, oh, I'm glad I did this. Here, I'm sorry that I did it. So I won't do it in, what's the commonality in the experiences where I wished that I hadn't written tests? What's the commonality in the experiences where I'm glad I wrote the tests? Then I'll use that to inform my behavior going forward.
Some people are actually writing in their blogs or discussing it, that people are today writing too many unit tests.
Yeah.
What is your experience or your opinion?
Well, let's let that be a big problem before we try and fix it.
Okay.
It's kind of one of these three bears things where, there's certainly too little, and there's maybe too much, and there's some place in the middle that's just right. Do you have Goldilocks and the Three Bears in Germany? Do you know this story?
I'm not sure. I don't think so.
Little girl goes into the bear's house and she eats the papa's porridge and it's too hot, and she eats the mama's porridge and it's too cold, and then she eats the baby bear's porridge and it's just right.
Okay.
So when I say Goldilocks, I mean, yes, you could have too much, you could have too little, and someplace in the middle is right. But I don't think people really know what too much really is. I would want to examine both the tests and the activities of a team that felt like they had too many unit tests to understand more about that. I've never achieved it, and I've tried.
Okay. What do you think? What makes a good test a good unit test, and what makes a bad test a bad unit test? I'm pretty sure you've seen a lot of good and a lot of bad tests.
Sure. Well, I think every test has got to tell a story. That is, somebody coming along later and reading it should be able to understand something important about the program. So my first filter is kind of a human communication filter. Tests should have in medicine they call it differential diagnosis, where they say, I'm going to order this test, and based on the results of this, whatever blood test, I will be able to rule out a bunch of stuff and confirm some other things. So every test should have this kind of, maybe this is an information theory thing, should be able to differentiate good programs from bad programs. If you have a test and it doesn't do anything to advance your understanding of good programs and bad programs, then that's probably a useless test. Right? If you took the space of all possible programs to solve your problem, almost all of them won't, and a few of them will. A test should lop off a big portion of that space and say, nope, any program that doesn't satisfy this test is definitely not going to solve the real problem. So there's a part of that. And then there's a sense of redundancy. If you have a bunch of tests that tell you exactly the same thing, then I would look to see which of them adds the least value and delete them. But they have to really cover exactly the same cases.
Do you think that all the other design principles that we all know for general programming also apply for the test code, like all these like dry and whatever?
Dry in particular, I don't subscribe to for test code, because I want my tests to read like a story. So one of the things, the features in JUnit is that you can, if you have tests set up in a superclass, it will be run before the test is run. So you can, extract out some common setup code between several different test classes. You do that 3 or 4 layers, and now the tests can be very terse, right? The test just says, some object, some message, here's the return value. Well, but to understand what's really going on there, to understand the story, I have to look at the class and its setup, and I have to look at the superclass and its setup, and I have to look at its superclass and setup. By the time I'm done with that, right, it's like telling someone the punchline to the joke without telling them the whole setup. It was the priest. It's not funny because you don't have the whole setup. Now, I hope I haven't offended any priests who listen to the podcast. But
did you observe any other really strange phenomena in testing?
Well, there's a couple of really weird ones. So there's one that I can explain that's really useful, and there's one that's just weird. So the useful one is that tests don't fail at random. If you take a population of tests and you run them while doing normal development, if a test fails, it's much more likely to fail soon thereafter. So for most tests, once they start passing, they'll never again fail. And this is based on looking at hundreds of millions of test runs, representing like 50 person years worth of development. So once a test starts working, it's just going to keep working. If it ever fails, then it's very likely to fail, much more likely to fail the next time you run it. So we use that in JUnit Max, which is this continuous testing tool for Eclipse and Java, to prioritize tests so that you run the tests that are most likely to fail first, so that while your attention is really on the tests that you're running, you get most of the feedback. Because really, if you could prove, and I suppose you could with a coverage tester and some static analysis, you could prove that if this test succeeded last time, it'll succeed this time. Then you don't even have to run it at all. This recent failure phenomenon is a heuristic that's a lot cheaper to calculate, because you just have to have a little bit of memory about what's happened in the past, and it lets you also prioritize the tests and say, well, let me run these first since they're seemingly fragile. Brand new tests run first, tests that have failed recently run first. So that's a true and useful phenomenon that I maybe wouldn't have guessed at, but makes sense. The other one is that if you look at any test suite, the time it takes to run the tests, some tests are shorter and some tests are longer. The distribution of that is a power law. So you'll have lots and lots of tests that'll run very quickly, and a few tests that'll take a very long time to run. If you create a histogram, plot it on a log-log graph, you get this really ridiculously straight line. So I can't explain why that's true, but I've seen it in enough data sets to believe that it's pretty much universal.
Would you, in such a case, would you split that into two different, let's say, suites or so, saying run the long running tests less frequently or only during the nightly builds or so to keep the running the whole tests quick?
Well, I think there's that would be certainly be one thing you could do, and you would. What that power law distribution says is that most of the tests can be run in a small fraction of the time because the outliers are so big. So that you could split it up that way. And indeed, when JUnit Max runs, it runs the short running tests first. What I haven't confirmed, and I would love to have more data on, is whether long running tests are more likely to fail. Right, kind of the worst outcome would be the longer a test takes to run, the more information that it generates, and the best would be if there's no correlation. So if you want confidence that the code is running, all you have to do is run the short running tests, and you get most of the confidence.
Can you tell us a little bit more about JUnit Max? You mentioned it, I think, some time now. Can you tell us a little bit more? What is it exactly?
Sure. So it's a continuous tester for Eclipse. So if you're in a project, Java project in Eclipse, you edit the source code, you save it, all the tests for the project are run automatically. And the metaphor is just like the compiler. So you make a change to your source code, the compiler runs, you get feedback right away. There's not a separate compiler tool that you go and execute in Eclipse. And with Max, there's not a separate testing tool. There's not a separate window you go to. You just get the feedback right away. So it came out of my frustration as I ran tests. The more I did TDD, the more I ran the tests, the more frequently I ran the tests. So take the JUnit test suite, for example. It takes about 10 seconds to execute. If you're running that 20 times an hour, which is probably a conservative estimate, and you wait till the end every time you run it, you can just do the math and say, depending on what my billing rate is, here's how much money per hour I'm spending on just waiting for the tests to complete. So I wanted to cut that down. Well, this test prioritization trick and the integration into the tests failed tests appear like compile errors. So it shows up in the right in your source code. You don't have to switch contexts when you get test results back. So the combination of that means that I only have to wait a couple of seconds before I say, yeah, that's good enough. Now I can get back to coding. Well, so you take every time I do the numbers, it seems ridiculous. So I'll leave that as an exercise to your readers to figure out how long they're spending waiting for tests and how much money they could save by having test results in say 10% of that time. It turns out to be a substantial number. So part of my motivation was that frustration with just I was spending more of my time waiting for test results than I wanted. And part of my motivation was I wanted a way to make a living programming. I can fly around, give talks, do consulting, and so on. But, I live in paradise, so I'd rather not do that. And I love programming. So, is there a way that I can make my living programming? So it was the combination of the theoretical work on tests and the behavior of real test suites in the wild, my personal motivation, wanting to get more out of programming and spend less time waiting, and this desire to create a way of supporting myself and my family and college tuitions and paying for goat feed and so on through an activity that I still love to engage in. And so that's JUnit Max.
Cool. Do I need to write special tests for it, or does it run just my general JUnit tests in version 3, 4, whatever?
Yep. So it's one way to look at it is it's a replacement for the JUnit test runner that comes bundled with Eclipse.
Okay, so no special code in my test code for that.
No, none at all. It just gives you the results with less weighting.
Oh, great. Where can I get it?
JUnitMax.com.
Okay. .com does not sound like open source. It's some kind of, you need to pay some amount for it?
Yes, so it's $100 a year.
Okay.
And every time I do the math to figure it out, it pays for itself about every 2 days in time saved.
Great. So we talked a lot about testing in the past, testing in the history. Let's now try to take a look into the future. What do you expect?
Well, the things that I see, I think JUnit Max is kind of my take on where the future is going, that tests will become as important to programming as the compiler is. When the tests are giving you value every minute, then you're willing to invest quite a bit more in creating them. I think there's a big trend coming in design for testability. So a system like Eclipse, I think, is beautifully designed, but it's difficult to write tests that are concise and run quickly for Eclipse functionality. There's certainly another way to design exactly that same functionality, for which it would be easy to write unit tests that would execute quickly and be isolated from extraneous failures and so on. But like exactly how do you do that, I think is there's a whole lot of learning to be done there. But as the value of tests increases, then the value of learning about those design skills goes up at the same time, and I think that there'll be a virtuous cycle of more tests driving the need for more testable designs, which make the tests less costly and more valuable, which leads to more tests. And so I think that's something that I expect. And then just running tests more frequently, more of the tests running more of the time. So kind of the next stage for something like Max, if you wanted to get more feedback per clock second of the programmer's experience, you'll need to start executing tests in parallel and in massive parallel.
Any other pearls of wisdom you would like to share with our listeners? the obvious last question.
Oh, no, I really I have grown. Okay, so here's my pearl of wisdom, which is be distrustful of pearls of wisdom. I don't trust the simple morals that people come up with at the end of their stories. I'm very happy to listen to the stories, but when they conclude, therefore you should do things just like I did them, I think it misses a lot of context. So listen to stories and tell stories. That's my moral, which isn't a story, so you can just disregard it.
Great. But then I have to ask you another maybe difficult question. What do you think will software engineering look like in 5 years?
The big trend is towards more frequent deployment, and that drives everything else. All the social changes that need to happen, all the technical changes that need to happen, the changes in practice, in language, and infrastructure. If you're deploying 50 times a day, your database has to look different. Your deployment stack has to look different. The current separation of ops and dev just has to go away. Marketing, sales, business models, everything changes when you're deploying very, very frequently, and that's a trend that is gathering momentum, and I don't see any place where that's going to stop.
Great. Maybe we should spend another episode talking about continuous deployment.
Oh, I'd love to.
Yeah, great. So for this episode, thank you very, very, very much for your time.
Oh, it's my pleasure. Thank you.
Thank you very much.
All right, I'll talk to you soon. Bye-bye.
Thanks for listening to Software Engineering Radio. Software Engineering Radio is an educational program brought to you by Hillside Europe. If you want more information about the podcast and all the other episodes, visit our website at se-radio.net. If you want to support us, you can donate to the SE Radio team via the website, or you can advertise for SE Radio, for example, by clicking on the Dig Reddit Delicious links and the /dot button. To contact the team, please send email to team@se-radio.net, or if it is specific to an episode, please use the comments facility on the website so other people can react to your comments. This episode of SE Radio, as well as all other episodes, are licensed under the Creative Commons 2.5 license. Please see the website for details. Thanks to Charlie Crow and the Podsafe Music Network for the music used in this show. The song is called Vegas Hard Rock Shuffle.